Okay, we have this next example. A small plane flying at 180 kilometers per hour at an altitude of 240 meters is to drop an inflatable raft to flood victims stranded in a flat roof. What or how far from the roof should a pilot release the package so that it will land on the roof? Okay, for example, we have this one. This is our plane that has the package, and we have here waiting for the package or waiting for the inflatable raft. So, according to the problem that the height from the roof portion is 240 and 240 meters, and it's traveling at a velocity equal to VO. Actually, the velocity of the package when it's being released is the same velocity of the plane. No, okay, it is being dropped, and somehow, since the package is from the plane, then there is what we call, how do we call that, absolute acceleration or absolute velocity. So that velocity is induced because of the velocity of the plane. So as this plane is traversing horizontally with a constant with a constant altitude, no? So say for example, this is the constant altitude. As it is traveling in that portion, no? Kana siya, no, mo travel na siya padung diha with a constant speed. So therefore, the package will eventually be dropped at a certain distance padung dira, no? Something like that. Ato lang tarongon. Okay. So we need a distance kung pila ang distance from this package here, no? Kana nga package ma-release para as the package is now being released, mabot na siya diri hantod sa kana diha. So pila kuno ang iyahang distance from this point of release padung sa na stranded sa roof. So we're gonna call that as x. So as you can observe, the initial point of release is here, and the final point is here. Therefore, um, the y value is found. The final point is found below the initial point. Therefore, the y value here is a negative value. No, so it is a negative value. So, what is the velocity of the package? The package's velocity is the same as the plane's velocity. So that's 180 kilometers per hour. Okay, so let's solve. We're gonna convert VO from 180 kilometers, no? So that's 180 kilometers per hour. We're gonna convert that into meters per second since our acceleration is in meters per square seconds. So this is one kilometer is equivalent to 1,000 meters, and 1 hour is equivalent to 3,600 seconds. So this is VO in terms of meter per seconds. So 180 times 1,000 divided by 3,600. So this is 50 meters per second. Okay. And then our y value is negative 240. Again, it's negative because the final position or the final point of the raft is found below the initial point. And then our x is the question. Kung unsa kuno ang how far from the roof should a pilot release the package so that it will land on the roof. So if we're going to compare the problems from the rectilinear to the curvilinear, so curvilinear problems are much easier compared to the rectilinear problems. So we're going to use the flight of trajectory formula. That's y equal to x tangent of the theta, and that's equal minus of the g times the square of x over 2 times the initial velocity square cosine squared of the theta. And by the way, theta, as you can observe, it's traveling horizontally, then therefore theta is 0 theta. So this is negative 240, and that's equal to x, which is the unknown value, tangent of 0, then minus, you have the 9.81, and you multiply it with the square of x, which is the unknown, divided by 2 times the initial velocity of 50, square that, and this is cosine of the square of the theta, which is 0. So cosine of 0 is 1, and then the tangent of 0 is 0. So we're going to have here as 9.81, negative, by the way. All the negative signs will be eliminated or can be cancelled because they're both negative on both sides. So this is now 240 times 2 times 50 square. Cosine of 0 is 0, and that's equal to 9.81 x squared. So our x, or the distance it's going to be released, is here. So let's get this done. This is 240 multiplied with 2 times 50 square divided by 9.81, and x is, you have the 240 times 2 times 50 square divided by 9.81. The distance must be released at 349 meters, 349.749 meters away from the position. Okay, what happened here? Right. So that is our final answer. So this is our example.